Here is a pretty simple algorithm I have been thinking about. Starting with 2, count the number of factors of a number, add them to the number, and then repeat. So starting at 2, which has one factor, we get 3, which also has one factor, leading us to 4, which has two factors. We go on to 6, 8, 11, 12, 15, and so on. This part is pretty simple. The next question is something that comes up a lot in math. If we take the inverse of these terms, do they converge or diverge? If we add them together, do they add to a specific finite number, or do they keep on going on towards infinity? If we add 1/2 to 1/3 to 1/4 to 1/6 to 1/8 to 1/11, and so on, do we get a finite number or an infinite number? My first guess was that these numbers converged. My reasoning was that eventually we would reach a point where the gaps between numbers grew quite large because we would be dealing with numbers with thousands or millions of factors. The differences between numbers could get arbitrarily large, and in my mind, that meant this series converged. But I reconsidered. After all, the inverse of the primes diverges, although very slowly, and the inverse of the primes also has arbitrarily large gaps in it. Additionally, this series specifically has a limit on how quickly the skips can grow. For example, the first time you can have a skip of 8 numbers is at 256, the first 8-factor number. There are 256 numbers between 256 and 512, and the fastest we can move through them is by movements of 8. And for the 512 numbers between 512 and 1024, the fastest we can move through them is movements of 9. So we are moving just a little faster to get through twice as many numbers. And in practice, the size of the skip is much smaller. And indeed, just looking at the first 70 terms, this series sums to half of what the harmonic series does, and sums to more than the first 70 prime numbers do. I am guessing this series diverges for these reasons. But there are a lot more numbers than 70, and perhaps my reasoning is faulty. I don't know for certain whether this series converges or diverges.